Hello, everybody. Thanks for spending your Wednesday evening with us. We know you have a lot of things going on, so we definitely do appreciate it. And hopefully, everyone can get something out of value from this presentation. I know it has a lot of good tidbits in here. So, going through structural issues. The structural portion of a home inspection is perhaps the single most important part of a home inspection. A home's structural integrity is often the issue of the greatest interest to home buying clients. I know we all hear oftentimes, oh well, I don't really, cosmetic concerns doesn't really, it's not meaningful. A broken window, not really meaningful. They want to know, is it safe for them to put their family in? And if the home is structurally unsound, naturally nothing else really matters. And they're going to look for something else, which is the reason why they look to us, the community of home inspectors, to make sure that they know what the condition of the home is like. So that's why it's so critical for the inspector to be competent in his or her ability to be able to observe, report, and note what they're seeing in a home inspection and transcribe that onto the actual inspection report. So but it's also not enough to just simply look at the foundation and the framing elements. Almost every part of a home is going to reveal what's going on with the structure itself. And I was touching on that before we actually started this evening, and you'll hear me reference back to this over and over again because I think it's really important. Because when and I also hear this from one of my buddies who's also a structural engineer here in my local area. Because when we're all looking at the home in its entirety, we're not always able to understand and instantaneously observe a condition right away. Oftentimes, it takes us going back to certain sections of the home for something completely different than what that structural issue was before we actually are able to connect the pieces or connect the dots, if you will, and put two and two together and say, "Oh my gosh, that's interesting." So, for example, and we'll also go into more depth about this later. But for example, when we see, let's say, a crack on the foundation itself, that's maybe a little bit more than a quarter of an inch in width, we note it in the report, right? But we may not think anything else of it until we actually get into the home. Let's say if it's in the front left corner of the home in a dining room. And so now we're inside the home. We've possibly forgotten about that crack is actually there, and then we're just going through the dining room. We're plugging in outlets. Yeah, we're plugging in our electrical tester, checking to make sure things are wired correctly. We're opening, closing windows and doors, and maybe in that corner where I saw the crack and noted it in the report, maybe I open up that window and I note that the window is a little hard. Is a little hard to open, and then I note it in the report, window hard to open, and then I move on and not think anything else of it. But then I go and then I go through the home. But then at some point in that inspection, something brings me back into that dining room, into a corner for whatever reason. And then all of a sudden, when I'm taking my time because I'm just standing in that area trying to note something else in the report, all of a sudden I look down and I think to myself, huh, the floor is really not all that level here or even if it's a smaller section of the floor. And then that's when you start to pause and think, it's like, wasn't this the area where I found and noted a crack on the foundation on the outside? Oh yes, it was. This was the same exact window that was hard for me to open and close, that I also noted in the report. And then now I'm also noticing that the floor is has a low spot here. Now you're starting to connect the dots. Crack on the foundation, window hard to open. I've got a floor that's starting to get lower. This might actually be a structural concern. So it's not just one condition or one defect. it's multiple defects in a certain area or areas, then lead you to conclude, hey, maybe we should have a structural engineer come out and further assess this because look at all these different things that I found. So that's why I think also it's so important um, to be able to take your time when you're going through homes. And oftentimes, what I see across the country are home inspectors that are trying to accommodate the volume of requests that are coming in, and they're doing pretty well at it, which is amazing. But I think there is also something to be said about making sure that you don't stretch yourself too thin. And what I mean by that is if you're taking on too many inspections to the point where you're still able to accommodate the volume, but you're just barely making it, what does that do to the amount of time that you're able to spend in the home? Because again, in order to be able to arrive to the conclusion that there might be something here that's worth noting and bringing in and recommending a structural engineer takes time. It takes time to discover those things. So, food for thought. Keep that in the back of your mind as you all are going through homes because it's incredibly important. The last comment that I'll make about about taking your time is I actually came across I had a conversation one time with a realtor where they were contemplating bringing me in, even though the inspection on the home had already been completed, already done, and they were very, 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 very close to closing. And the realtor who uses us, they uses us as their first choice inspector, had said, "Hey, Phil, so I'm bringing this to your attention. When do you think you can come out? Just so you know, it's already been inspected, but there was a concern there." That the initial inspector didn't bring to the family's attention, and now it's becoming a much larger concern in this conversation as this home moves closer and closer to the closing table. And she gave me the address and said, "Do you see anything? Do you see anything from that listing photo?" And almost instantaneously, I said, "What's with the crack? What's with the stair step crack in the front bay window?" It was an old it was a historical home somewhere in the city. And she said, "You're right. That crack was missed. That crack was missed during the home inspection." And also, they think that that crack also may be tied and possibly explain the reason why the floors on the second floor are bouncy, like a trampoline. But I share that story because if you're moving really, really quickly to try to accommodate the volume, you may get unlucky and not see that stair step crack, even though it's on the front side of the home. And you may also, I don't know how, but you may also miss that the floors are bouncing on the second floor. But when I was shown the front elevation of the home, I could instantly see the stair step crack. So it's important. Take your time, take your time, and I think that's the right thing to do when we go through homes. So okay, enough said. So from a wall standpoint, two types of walls. There's a load bearing wall and a non-load bearing wall. So the non-load bearing walls naturally that those wall systems aren't supporting anything. Load bearing walls, we need to be very cognizant of. We need to be very, very cognizant of whenever we interact with those. I'm sure a lot of us have gotten the question over the years about, hey, can I move this? Can I move this wall? Can I create my dream home with an open concept? And is it always easy for us to determine if something is load bearing or not load bearing? It's not, because most of the time the drywall is going to be up. But it is still important to understand the difference between the two and some of the specifics in between. So when you are at let's say, if you are, for those of you that are doing a pre-drywall inspection, not always, but most of the time you can tell if the wall is a load-bearing wall because you will have what we call a double top plate. So two pieces of horizontal framing on the top of the wall. If it's a non-load bearing wall, you will typically see that it's only just one piece of horizontal framing there. So Can you alter that load bearing? Can you alter that load bearing wall? Possibly, but it's going to require engaging a structural engineer to help determine what is the best course of action in order to be able to adjust that wall, in order to be able to create a look and feel that the family actually wants. But sometimes when we're going through homes, because the majority of the home is actually going to be covered in drywall, structural weaknesses won't always be so immediately discernible. Sometimes the weakness in the wall would only be discovered over time, which is the reason why we say that we will comment on conditions that are present during the time of the inspection. So during the time of the inspection, we can't predict the future, and because the majority of the home is covered, it's just one of the it's one of the limitations that a home inspection has. So you can see at the very top here. Those are trusses that are sitting on top of that load bearing wall. So trusses designed by structural engineers and their architects to be able to carry a certain load of that roof system. Um, and then you've got, let's see here, right here, you've got a bearing beam helping to support the flooring system. It could be steel, it could be wood, it could be engineered, but it's helping to support that flooring system there. You can see here they've got it's being the whole entire system is being supported with masonry columns to support the system. Masonry columns, vertical compression members, right? Who's the height? Okay, so the height of that column, it has to exceed three times its thickness in order to be able to do its job, and whose width is less than and one half times its thickness. So a column could be narrow, it could be slender. It's going to be a vertical compression a vertical compression member. So oftentimes when we're going through homes, more of the modern day homes, oftentimes we'll see a support post, right? Metal support post known as a lally column. So it's going to help create, or it's going to help transfer that load from up above all the way down, and then into the ground, and then through the footer, which is what we call a continuous load path. Moving to the right diagram here, you'll see so tiny studs here, known as cripples, that are around a door opening. You'll see this vertical member here, which is called a header, horizontal piece of framing that's meant to help support that opening. We're actually directing the load around the window opening, creating that continuous load path around the opening. And then on the sides of the windows, you've got the shorter pieces of framing known as jack or trimmer studs. And then the longer pieces of framing, those are your king studs that are helping to transfer that load, create that continuous load path down into the next floor. So what you'll see for those of you that are doing pre-drywall inspections on new construction, when you are looking at the king studs here, when you're looking at the jack studs, remember, don't just look to make sure that they are in place. Also, make sure that they're actually cut long enough to actually be able to help create that continuous load path, and actually do what it's supposed to be doing. It's really I just thinking about over the years of myself doing inspections now, a lot of the different things that I took for granted when I would be a part of webinars and CEs, and they would say, this is what a jack stud is, this is what a cripple is, this is what a king stud is, this is a joist. It's one thing to know about the different systems, but it's another thing entirely to be able to see and know what are the pitfalls or the shortcomings when it comes to actually installing these different things. because oftentimes builders just it's yeah, there's just not a lot enough people to go around. Sometimes shortcuts can be taken, and sometimes you'll have gaps in the framing. Another common condition that I see is so when you look at the king studs, so you want to take a mental note in terms of where those windows are, where they're placed in the home, and then once you're done with that particular floor, you want to go to the next floor right beneath it and look right underneath where you know that those windows are placed, and make sure that there is some type of support framing system there to help create that continuous load path right from this king stud here and then down into the next floor. And oftentimes, what you'll see the builder do, and which is what we don't see on on a resale or on a finish home for like a final inspection, because the drywall's in place. You'll see, or hopefully you'll see, squash blocks, so very short studs, almost like a cripple, but squash blocks to help support that king stud assembly system and create that continuous load path down into the next floor. And hey, maybe sometimes the squash block system, maybe it wasn't cut long enough. Maybe they actually didn't secure the squash block system directly underneath the king stud, underneath the window, to the wall and to the framing system. And sometimes you can just literally remove the squash block system, helping to support the load from above, right out from its position. Really interesting. And then again, because if it's not cut long enough, then it's not helping to create a continuous load path because there's a gap. So that's why again, I think that's another real example why it's so important to make sure that you're taking your time in these homes, because a lot of the meaningful conditions and defects, if you will, that need to be noted and brought to somebody's attention aren't always the most easily discernible until you're there for a for a good amount of time. Foundations and managing moisture are two conditions that will pop up on almost every single inspection, especially when it comes to resales. When we're not managing and controlling the moisture as much as we can, what's going to naturally end up happening is you're going to have conditions where water is transitioning into the home. You're going to have conditions where the foundation will start to crack. You can have conditions where the foundation will start to move. And then it creates hosts of other issues inside the home. So as we all know, if since water is this food source for biological growth, mold, if water is transitioning into the home because the gutters are not daylighting or discharging the water as far away from the home as possible, then you could have mold in the home, which can also impact the air quality. So, very, very, very important to make sure we're able to tell the families if the grade needs to be adjusted, if the gutters need to daylight or discharge further away from the home there. Now, one of the other things that we would not be able to see if we're at a resale that we might be able to see when we are helping a family build a home from scratch and they haven't backfilled the foundation. So that's the act of actually putting the dirt back into place, right? Next to the foundation is damp proofing. So oftentimes the damp proofing, nothing is ever going to be waterproof, but water resistant. That damp proofing is going to help make the concrete foundation as water resistant as possible. So important for those of you that do have the opportunity to be able to get out there and take a look at the foundation before they backfill it. You will find oftentimes that the foundation system will have additional areas where they could actually stand to apply more damp proofing. And sometimes you'll find that there is bare concrete, not actually covered in damp proofing that could absolutely absorb the water and over time transition into the home. I've seen it before where I will help a family either for a resale, but also for new construction. where the where the family will say, well, Phil, I'm calling you out today because I have this humidistat here in the basement, and the humidistat has been reading 65, 70% relative 70% relative humidity, and the builder just can't find, just can't determine where, why is the humidity so high, and they'll just rack their brain all over and around the HVAC system trying to determine why is it creating so much humidity. But one of the difficult parts is that, hey, can anyone determine if the entire foundation is actually sprayed with damp proofing? No way to know. So that's why it's so important to advocate for a foundation inspection. If you for those of you that do have the opportunity to help build from scratch. Now moving over to the right to the right diagram there, a little bit of a closer up view of the actual framing system for the home. You'll see here on the top, you'll see floor, top right corner, floor girder, fancy term for beam, and then also floor joist there. I think it is very, very important to know that if you're on a resale or if you're doing new construction, very important to look at as much of that framing system as possible, because who knows, maybe somebody drilled a hole that's maybe just a little too large in that girder. Same thing for a joist, or they notched. I think we've all seen notches, not notches in joists that can make the system weaker. So very, very important when we are in those unfinished areas in the home, whether it be a crawl space, whether it be a basement unfinished area, to really take our time and look at those framing components to make sure that we're confident that we know what the condition is like. So the last story that I'll leave you with before we go over to the common foundation types. So the inspection that I was at in the morning, I was in the basement unfinished area, and I had pretty much done the whole entire basement unfinished area room. And then at that point, I started looking up at the ceilings. And I started looking at the joists specifically. And one of the things that I always tell myself or remind myself, but then also remind my other inspectors is, again, one, take your time, but then also two, if you think it's safe for you to do so, you should always try to look or fit yourself into those hard to get to spaces. Again, only if you feel it's safe to do so. Because if it's hard for you to get to, if it's hard for you to fit into, do you think it's hard for that original contractor or for the builder to get to? Yes. And also, if it's hard for them to get to, or if it was hard for them to get to, if the home has been in existence now for 20 years or 30 years, do you think that you will find defects? Yes, because it's hard for them to get to begin with. So, long story short, I looked up at the ceiling. This was right above the builder's HVAC system there, and there was some return ducting that was in the way, and some plumbing that was in the way, and electrical wiring in the way. So I was practicing what I preached. Got myself on a ladder, took my time, slowly poked my head around, and guess what I found? Found joist hangers to help support the flooring system. So normal, right? Joist hangers. And they've got two sides to the hanger system. So you've got the left side and then the right side. So left face, right face. And typically the way that the contractors will do it is they will tack one nail or install one nail on each side of the face in order to, and then they'll do that for all the hangers to make sure that the hangers are level first before they go in and install the other nails. But when I was able to finally squeeze my head in there, do you think they had all the nails installed on both the left and right face? No, they only had one on each side. It's a joist hanger. So very, 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 very important to take your time. Oh, and then I was able to then squeeze my camera through. I was holding my phone, and then try to wiggled my way through the other through the other to the other joist, and same thing, one on each side. It happens. They forgot to tack them up. So take your time. It's important. Okay. All right, so common foundation types. So here on this particular side, we've got a ground supported slab. The next one that we'll review is the crawl space slab. But so with the ground supported slab, the reinforced concrete slab is poured on the ground. But there's usually a gravel or stone layer beneath or below the concrete slab and above the undisturbed soil. So the footing is going to be below the foundation wall and, as we discussed, supports the foundation. So superstructure. So this is the superstructure. It's a term that references the load-bearing wood framing above the exterior wall of the actual structure itself. So hopefully you can see in the middle there. That's why it's actually labeled superstructure. Um, let's see here. And then if you go to the top right diagram there, you'll see a couple things I think are pretty neat to note. So one, you'll see a text here that says sill gasket. So what is that sill gasket all about? So that sill gasket is sandwiched or is in between. So in this particular diagram, a CMU, a concrete masonry unit, right? And the bottom part of the wall. And now we all know that the bottom part of the wall is called the bottom plate. So why is it important to have a sill gasket there? Polyethylene, actually. But why is it important to have it there? Because it's acting as a capillary break, acts as the capillary break. So then as the water transitions upwards or moves upwards through the foundation wall, hopefully that sill gasket, polyethylene foam, it just gets rolled out. It just gets rolled out. So you roll it out and then you put your wood frame on top. That will hopefully stop the water from coming in contact with the wood frame. So so it's going to help protect the structure. So one of the things that you'll find that if you're in the garage, let's say, and you just kind of like kneel down or look underneath the wall, sometimes you may actually come across a completely missing section of the sill gasket, and you can see straight to the outside. It happens. Sometimes you might actually see a whole section of the wall that is just completely missing the gasket altogether. It happens. It's important to know that that gasket is there for a reason. Now, looking at that same diagram, so when you look at the bottom left corner there, you'll see a couple different terminologies being noted. So one says filter fabric, and then the other one says perforated drain pipe. So the filter fabric. So actually, let's start with the perforated drain pipe. So oftentimes, what we call this it's called drain tile. Oftentimes, it's going to be black in color, and it wraps around the entire foundation. Now, the drain tile or drain pipe is going to have holes in the actual tile. And what it's doing is it helps to collect any water that the grade can't direct away from the house. 6 inches of fall for the first 10 feet, right? And then that filter fabric is placed on top along with gravel. That filter fabric is placed there on top of the drain tile to try to help prevent any type of like dirt or debris from actually getting clogged in that drain tile system. That's helping to to try to keep the water away from the home. So where does that drain tile go? So that drain tile most of the time will actually lead underneath the foundation of the home, and then underneath the floor, the concrete floor, and then into what we call a sump pump. Others will call it a crock. That's the actual fancy term. And then as the water level rises, then a motor turns on in the sump pump system and then kicks the water away from the home. So that's what that is all about. Let's see here. All right, before we move on, AJ, do we have any questions on that? I know I just went over a whole I just went over a ton.
Nope, no questions yet.
Awesome. Okay. All right, AJ, if we can move on to the crawl space. Okay, so crawl space construction. So crawl space, it's an accessible space, right? Between the ground and the bottom or the first floor of the home. So crawl space, it's referred to as an underfloor space. And not a basement. So it's a story of the house that's entirely above the grade, above the ground, and they will typically call that's the main first floor. So when it comes to crawl spaces, very, very, very important to one when you're so if you think that it's safe to enter the crawl space, make sure that you're wearing proper PPE, personal protective equipment, safety first, right? So you want to make sure that your head is covered. You want to make sure that your eyes are covered. Make sure that your body is covered. I know some inspectors will wear like a Tyvek suit that covers them from head to toe. Others will wear coveralls or overalls that'll cover themselves up. Others will also have gloves on as well because crawl spaces you don't know what is physically there. So make sure you're covering up as much as possible. Another one that's also really important from a PPE standpoint is some type of goggles or glasses, but then also a mask as well. So remember, the crawl space, it is a enclosed space, confined space, right? So you want to make sure that you're covered as much as possible. So when you're in a crawl space, a lot of things can be found in a crawl space because it's very uncomfortable, right? That confined space. So you could encounter everything from from supports such as the foundation wall itself to posts leaning, moving, missing, possibly due to either a gutter daylighting too or discharging too close to the home, right? Grading, not falling 6 inches for the first 10 feet. So we want to make sure that the soil is solid as possible. You can see some really interesting repairs. You could see damaged floor joists. You can see rotting floor joists because maybe there isn't a moisture vapor or a moisture barrier or a vapor barrier on the ground. Incredibly important to have that because if you don't have that, then you're going to have structural issues that are going to create concerns for the family. But then also, you could have other issues too because it's just hard to get to open junction boxes, damaged electrical wiring, plumbing that's leaking that no one ever knew about because who spends time in their crawl space, right? I don't, spending times in front spaces. I don't think that's the first on everyone's to-do list. But you could see standing water in the crawl space that is now impacting those structural components of the home because no one knew about it for years. And then you go in because now the home is built and you say, why is this support leaning? Oh, look at this standing water coming from the sewer drain line. So very, very, very important if you think it's safe to do so, make sure you get a good sense in terms of what that overall condition of the crawl space is like to make sure that the family has a good understanding in terms of or your client what they are actually getting into. AJ, can you move on to the next slide, please? Common framing styles. Okay, so common framing styles. So two types, platform, which is the more common one that we see today, and then you have balloon. So balloon framing is actually coming back, which is really really interesting. Oftentimes, I'll see balloon framing if it's when I'm in a pre-drywall inspection, and oftentimes a lot of like the high-end builders are doing a lot of balloon framing, which is really really interesting. But the balloon framing system, so it's the balloon wall studs. They extend from the sill, so the bottom part, right, of the foundation, all the way to the top plate of the second floor. So continuous. And then the platform framed wall, on the other hand, it's independent for each floor. So why were we getting away from balloon framing and switching over to platform framing? Balloon framing, there's that concern that it's easier for fire to transfer from one floor to the next floor, and naturally that's a safety concern. Now, one of the ways that the building community is trying to mitigate that risk is by using fire stops at each level. But is it easy to see fire stops? So, fire stops, another way to describe it is a fire blocking system. And oftentimes you'll see a fire stop or a fire blocking system is where you'll see a contractor. I also call it like a builder's vendor or like a builder. They're taking this spray foam. Oftentimes it's going to be orange in color, called fire. The colloquial term is called fire block. It's actually called draft stop. And what they're doing is they're any hole that's transferring from one floor to the next floor. They're spraying it with this spray foam to try to seal off the opening as much as possible to slow the spread of fire. Balloon framing. It's really interesting, but it can be mitigated by adding fire stops. So in platform framing, the joist can be comprised of any number of individual floors or platforms that the wall framing components are constructed of. Hence the term platform framing. So platform framing, it's the most common, as I was mentioning, that we're going to see today in home construction. It's made up of joists that help to support the walls, the beams, or the girders, and covered with either plywood, if it's an older home, right, or an OSB subfloor, oriented strand board. Let's see here. So floor joists, again, as mentioned, different types that a particular builder can use, or that you would just encounter when you are out and about. Solid dimensional lumber, or I-joists, or open web floor trusses. Now, um, notice, so just take note of the different types of joists that I just mentioned. Most of the time, when if you're going into a newer style home, you'll most likely encounter an I-joist system. I think the most common one that you would see is a TJI. It's almost like saying Kleenex. Instead of calling a tissue, they would call it a Kleenex because it's just everywhere. But TGI joist is what you would see there, or you would see an open web floor truss system. Oftentimes, you would see the latter of the two, just because it's just easier for the builder to be able to work with that particular type of material, to be able to get the different types of systems that they need in there, whether it be HVAC ducting, whether it be plumbing, whether it be electrical wiring, or what have you, and still make sure that the structural integrity of that support framing system, so the joist, is still sound, because you can only notch, cut holes in certain places, and still just have that floor joist system ready to use. Okay. AJ, would you mind moving on to inspector safety, please? So you've heard me mention it several different times already. One of the most important things when it comes to inspecting a home is to make sure you go home. Most important thing. So inspector safety is definitely the most important thing. It's paramount. If you think it's not safe, do not do it. It's more it's and then make sure, but also make sure that you let the client know that there is an inspection restriction for that particular system. So if for some reason, if you heard a buzzing system, since we're talking about safety, I'm going to digress a little bit from the actual structure, but I think it's important. So if for some reason, if you heard a consistent buzzing noise on an electrical panel, naturally you're not touching that electrical panel, and then you're going to, for safety reasons, and you're going to put an inspection restriction on the report itself. If for some reason, if you felt that there might have been a condition that's tied to the flooring system for the home, and you just absolutely wanted to go into the crawl space to see and learn and discover more, but for some reason you felt you couldn't fit into that crawl space, or for some reason you felt it was unsafe, don't do that, right? Just put an inspection restriction on the crawl space itself and say, at the time of the inspection, I was not able to access said crawl space due to these limitations. Recommend to have a general contractor further evaluate that entire space because I discovered ABC while inspecting the home. And same thing for the attic. If for some reason, if the attic was not accessible for any reason, and you were on the exterior of the home and you saw that the roof was sagging, um, naturally you want to put an inspection restriction, and say I wasn't able to inspect the attic during the inspection itself, wasn't able to fit in the attic for whatever reason. I did, however, observe that the roof ridge line was sagging. Recommend to have a roofing contractor further evaluate the entire system. So on this particular diagram, you can see an inspector standing on a ladder. I'm sure we are all doing it, but it's important to know we always want to make sure that we're using the 4-to-1 rule, right? When it comes to setting up ladders. So what is the 4-to-1 rule? So for every four feet up from the ground, for every 4 feet up, you want to make sure that the base of the ladder is 1 foot. So 4 feet up means the upper point of contact. So wherever that the top of your ladder is touching, so that would be the upper point of contact, and then move the base of the ladder out there, 1 foot, right, for every four. That way the ladder is as stable as it can be. But when you're up on the ladder, make sure that you're always facing the ladder, right, when you're actually climbing. Make sure that you're wearing some slip resistant footwear. Make sure that those are rubber soled shoes in order to do it. And as mentioned before, are we required to walk on a roof? No, we're not. We're not required to walk on a roof. If for some reason, if you think it's safe to do that, more than welcome to. But remember, safety first. And then also make sure that whenever you're transporting your ladder, make sure that it is that make sure that it's secured, right? When you're in the attic, a lot of different safety concerns for the attic itself. So that's the reason why. Are we required to walk through the attic? No, right? There's most of the time there isn't a floor, depending on the house that you're inspecting, but there's probably not a floor in the attic, so it's dangerous to walk through it. So some of the different concerns from an inspecting the attic standpoint is you could actually put your foot through the ceiling from beneath. You could actually fall through the ceiling. So remember, safety first. You could bump your head on things. You could bump your head on the rafters. You could bump your head on the collar ties that tie the rafters together. Bump your head on the trusses. Breathing insulation dust, not great. You could be coming in contact with shiners. So that's where roofing nails didn't actually penetrate didn't actually penetrate the roof trusses, and then now your head is touching the tip of the nail. There could be exposed electrical wiring up there. That's not in a junction box, not capped. So it's important to know that safety first when it actually comes to the attic, and the same thing goes for the crawl space as well. AJ, can we move on to the next slide? So it'll be property lot. Okay, so several different things that a home inspector should take note of when you are out and about. So when you are on the exterior of the home inspector should take note if the home is on a steep slope. So the reason why you want to just automatically draw that to your attention if it's on a steep slope is because if it is, then it's a little bit more subject to erosion and movement, right? You also, as we had mentioned already, negative grading. So when you are out and about on the exterior, you want to make sure that the grade falls 6 inches for the first 10 feet away from the home. to try to manage and control that moisture as much as we can. Another one that is important to note, so wood siding. So wood siding, as well as the sill plates, so bottom sill plate, bottom part of the wall, they need to be at least 6 inches above the grade, above the finished grade. So again, why is that important? We want to try to keep any wood type of product, anything that's susceptible to water damage, away from moisture as much as we can. Rotten sills, so like the bottom sill, can be crushed by the weight of the home over time, especially if it's constantly being in contact with water, which can lead to settlement of the home. And rotten sills weaken the anchoring of the framing system to the foundation wall itself. So one of the things that's very important, so that we don't oftentimes see on a finished home, but we can see, depending on when we go in, if we're looking at a home before they hang the drywall, is you'll see anchor bolts stationed around the entire bottom sill plate. So if the and it's meant to help prevent hold down, so pin down the wall, but then also help prevent the wall from what we call racking. So that's the movement from side to side. Um, and oftentimes, what we'll see is not enough anchor bolts, and sometimes you'll also see that the anchor bolts aren't even tightened down, which is really interesting. But even if we have enough anchor bolts in place, and the anchor bolts aren't loose, if the bottom sill is rotting over time because it's just way too close to the finished grade, and how do we define way too close again? 6 inches, right? Then it's essentially not going to be able to do its job, and we've weakened the structure of the home. So very, very, very important. And oftentimes, I think we've all at some point come across homeowners where they're mulching they're mulching the exterior of their home, and they've got a really nice mulch bed, right? They've got a really nice thick mulch bed. But it's so thick that it's coming in contact with the bottom part of the wood siding or the bottom part of the sill plate there, and we need to remind them, hey, we need to make sure that we're keeping all of this moisture away. So, and then the other one that we haven't touched on yet, this evening together, is vegetation. Vegetation, very, very important to be cognizant of where the vegetation is located in the home. So here you can see on this top diagram, where it says tree, and then you've got the roots. So over time, this can happen where the tree has become so mature that the actual roots are now actually helping to support the footer in the foundation walls itself. And also sometimes you can see, or you'll find that the tree roots are actually exerting horizontal pressure onto the foundation wall itself, and then you could actually find a horizontal crack actually coming from that tree. So very, very important to take note of what the vegetation is like. So one, make sure vegetation isn't too close, right? Because we don't want the vegetation to be touching the home to a point where it's actually exposing the home to water. But then also, are there any large trees around this home? And if there are, and if there is a large tree around the home, make a mental note of that. And then when you go into the basements, and as well as the unfinished area, because you'll be able to hopefully better get a better sense of what's happening in the unfinished area. See if you can tell if those roots are impacting those foundation walls, because sometimes you might actually discover that. Okay, so we're approaching 6:40, 6:49, 6:49 right now. Any questions?
Could you comment about modern frame? It seems the head is not required in the door and non-bearing wall.
Good question. Okay, so this the so so you saw me smile, because I will give you the default response, because it is what how you should look at it. Okay. So if for some reason, if something looks to be off, it may not actually be. So if something looks to be off, it may not actually be. What do I mean by that? So if you are at, let's say, the new construction site and you see something that looks to be off, it's important to note, to ask, to put in your inspection report, have the builder check their plan details to see if this is what they want. Because remember, the home is what was designed in a certain way to hold a certain amount of to hold a certain amount of weight based off of what their overall grand scheme was for the home itself. So just because it's not how you and I would build today, or just it's because it's something that you typically don't see, doesn't mean that it's not okay. Builders will always build to their plan details and they cannot deviate from that because it's already been approved. It's been already been approved and good to go and good to use. So somebody has already said, yes, you can do it this way. So important to say, hey, yes, I don't see ABC in this particular location. I typically don't see it done this way. However, I do recommend to have the builder check their plan details and see if this is what they want. Now, if you're at a resale, if you're at a resale and you come across that condition, then you would also note that in your report. You would frame it in such a way where where you would say something to the effect of, so at the time of the inspection, I observed that header was not installed. Typically, a header, and notice I said typically. So typically, a header is installed over the door, over the window opening, in order to create a continuous load path around that opening and then down into the next floor. Recommend to have a structural engineer further evaluate this and to determine if a repair or replacement is needed. So is it our role to be able to say that this is ready to use, it's not ready to use? No. Our role is to observe and note concerns that we see in the home, and then recommend a certain contractor to come out and further evaluate. So, good question.
Truss plates pulling apart at the joints. Found this during a final inspection on a new home. I did not do a pre-drywall inspection.
Okay. Hey, good catch. Good catch. Okay. So my favorite type of inspection is a pre-drywall inspection. If you're catching gaps in the truss framing system, amazing. Because it's very it's a very obscure, if that's the way to describe it, if that's the right term to describe that. And it tells me that you're taking a decent amount of time in your homes because it's hard to find. Okay, so that being said, what are all those gaps about, or parts of the truss framing system pulling apart? So there's something that they call the TPI, the Truss Plate Institute. So the Truss Plate Institute will initially dictate how we should feel about a condition like that. So oftentimes, so let's say, so if you can picture a truss, right, like a big triangle. So you have the top chords, right, of the triangle, and then you have the bottom chord, and then sometimes you have framing in the middle, which are called webs. So oftentimes, what the TPI will say is that if you have a gap in between the framing that is more than eighth of an inch. If the gap is more than an eighth of an inch between the parts of the framing system, so pulling away or it just wasn't cut long enough, then that condition is most likely exceeding the truss fabricator's tolerance. Condition should be shown to the fabricator to determine if a repair is needed, and if so, what's the prescription. Reason being is the reason why they say that is because of all of these trusses, right? They're in different sizes and they're meant to hold a certain amount of weight. So they've already done the load calculations in terms of like how big, like, so what the tolerance is. What is the tolerance for a gap like that? So sometimes you'll actually see the builder say, yes, I totally get I totally get what you're saying. Yes, this gap is more than 1/8 of an inch, but based off of our design, and how how big these trusses are and the type of wood species that we're using, so on and so forth, our design can actually take more than that, more a bigger gap than that. Now, what's really interesting is that so that would be for the top part of the truss, the triangle, right? And then you've got the bottom part of the triangle. Now, if there's a gap in between the bottom chords, the bottom part of the triangle base, it actually becomes even tighter of a tolerance. It goes from an eighth of an inch to 1/16th, 1/16th of an inch. So they don't want anything larger than that. And the reason being is because the majority of the weight is actually going to be held at the bottom part of the triangle. So they need to make sure that those two connections there are super tight. That's the reason why there's a super tight tolerance. Now, so a real life example. So there's so last thing, and then AJ, we can get back into the presentation. You've got me going on. You can tell that I love doing this stuff. Okay, so all right, so you've got truss hangers, right, that you're actually going to see in the attic, and you can get a really good look at them during the pre-drywall inspection phase. And this is also the reason why it's so important for everyone to do pre-drywall inspections, because when you think about it, can you see every single truss hanger before the drywall gets hung? Most likely, yes. You'll be able to see the left face, you'll be able to see the right face, so right side and left side, right? And you'll be able to see, are there circular nail holes there, are there triangular shape holes there? Because depending on the manufacturer, they're going to say on their bulletin, so how to actually do things, or this is why it's important to know. They'll say, hey, any circular hole needs to be filled with a nail. Any triangular shaped hole is optional unless specified on the actual plan details itself that it actually needs to be filled, because they're increasing the holding power of the truss system itself. Now, when you look at, so let's say Simpson Strong Tie, for example, the manufacturer Simpson Strong Tie. Now, for they had different types of hangers. So one is an HUS. So they have two different families that you'll typically see out and about. So one is the HUS series of truss hangers. So what they say is that you cannot have a gap between the carrying, so that would be like a girder beam or a girder truss, between the carrying and the carried member exceeding an eighth of an inch between the two components. And the reason being is because there is a gap larger than that, then the bracket itself isn't strong enough to be able to hold the weight. And then and it may exceed the actual allowable limits, and a repair may be needed. Now, keep in mind, so that, again, that was for the HUS family, eighth of an inch. That's how big the gap can be. Only the HTU family of truss hangers can actually have a gap that's larger than the eighth of an inch. It actually can go up to 3/8 of an inch before an actual repair is most likely needed. But again, it's not our job to know that the repair is needed. Our job is to know, hey, there's a gap here. This gap looks to be pretty large. You should probably show this to your builder and their truss fabricator so they can determine if a repair is needed. But where I'm going with this is that, so for the HUS, so I was at a pre-drywall inspection the other day, and I saw an HUS truss hanger being used. There was a gap of more than an eighth of an inch. The gap was probably about half an inch, but not three. But actually, no, the gap was more than eighth of an inch, but not half an inch. And I put it into the report to have the builder further evaluate it with their truss fabricator. And the response back from the truss fabricator was, based off of our design, we can actually have a gap of up to 3/8 of an inch, even though this is an HUS hanger and not the HTU hanger. So that's the reason why. So long about way of saying that's the reason why, as home inspectors, we're not required to know what the fix is. We're what we are there to do is to observe the notes in the report, what we're observing, what we're seeing, and then bring it to somebody's attention. That way they can further evaluate it. Did I answer the question?
Phil,
Yeah.
what are your three most common finds during a pre-drywall inspection? And what's one recent issue you've come across that made you stop and think, okay, that's definitely not something you see every day? I'll be attending a drywall course in March in Boulder, so I'm trying to soak up as much as I can.
Okay. Okay. So AJ, say the question. Can you repeat the question one more time?
Yep. What are your three most common finds during a pre-drywall inspection? And what's one recent issue you've come across that made you stop and think, okay, that's definitely not something you see every day?
Okay. Good question. So I call these gimmies, from an inspection standpoint. Okay, ready? One, loose bolts, loose bolts on the bottom sill plates, almost a given. I will also tie that in with loose bolts on support posts and beams. Isn't that crazy? Loose bolts on the sill plates and loose bolts on the support posts, to beam connection, so girder connection. And then whenever they have two pieces of beam girder tied together, loose bolts connecting them. Crazy, but it's almost a given. Which is the reason why, I try to check almost every. I try to get to check any bolt that I can get to safely, because I know there's a high probability that it's going to be loose. Um, Condition that I encountered where, where it was just out of the norm. So to me, so that's kind of relative, because the more you do something, I feel as if you get jaded because you just see the same things happening over and over again. So my version of normal may not be somebody else's version of normal. But just like defects across the board, are normal to me, just because I'm doing it every single day. But I will say, if there are just an incredible copious amount of defects popping up all over the place, that's when I will actually stop. And then, which actually doesn't really happen all that often. But off the top of my head, I can probably count, on one hand, probably a lot less than that, maybe two times on a pre-drywall inspection where I literally stopped. I literally stopped, called the client, and I said, "Hey, so how much do you love this house?" So, because remember, we're even so over time, and I know there are a lot of you that are already out there, that are very, 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 already very proficient at what you're doing. But at some point, our knowledge level stops, because we're still a generalist, right? We're not the structural engineer, we're not the architect, we're not the HVAC contractor, and we have limitations to our knowledge. But the more we know, just the better we are. So there were a couple times where I actually stopped. I called the client and I said, "How much do you love this house?" And I said, "Why?" And I said, "Well, because this is starting to exceed what I would actually describe as normal." It was just an incredible amount of defects, even very, very, very simple, easy stuff, that the builder was missing. Whenever a home inspector is allowed in, that's not always the case, but it's this is typically the case. Whenever a home inspector is allowed in to do a pre-drywall inspection, it's typically only after the builder and their vendors, so their subcontractors, have swept through the house themselves. The municipality has also probably already swept through the house, and everyone's approved it. Everyone has already said that this is amazing, and it's ready for the next phase. We don't even know why you're here. Um, so when you start to find a lot of things in the home, a lot of easy stuff, that's when you really have to start, pause and say, "Oh my gosh." So one of the things that I saw, that was happening a lot is, and it's hard to picture, but this is one of the things that we would be able to talk about later on a pre-drywall course. Teaching a pre-drywall course in Boulder, Colorado, by the way, next year. But so whenever you're using the I joist system, right? For the floor joists, you'll see the builders, attaching joist hangers, to the I joist, and then onto another type of I joist system. Now, remember, there's a top flange and a bottom flange, and then there's the web. The web is very, very thin. So, are we supposed to be nailing, the joist hanger directly into the web? No, you're supposed to be using what we call backer blocks that slide into the web itself, that are cut tall enough to contact the top part of the web and the bottom part of the web. And sometimes you'll actually see that the backer block is too short, which is a completely different issue. But that gives a joist hanger something very solid to nail into, so that way it's just strong and ready to use. And in this house, they had a whole bunch of joist hangers being installed with no backer blocks for the nails to actually be secured into. Really interesting. But family ended up buying the house. We did the pre-drywall inspection. We did the final inspection. The project manager actually ended up being transitioned into another neighborhood. And then yeah, good question. Okay. So when we are inspecting the exterior and the foundation, so here are a couple different things, or actually not a couple, that would be two. Here are several different things that we should all be looking for and noting in the reports, but then also whenever we see something on the outside, you want to take a note or take a mental note in terms of where these things were. So when you're inside the house, just make sure that it's not that those conditions aren't tied to something else inside the home. So mortar joint condition, right? Mortar joint condition. So if you see that, the mortar joint is damaged, deteriorated, missing, maybe it's just old age. Maybe it's just old age. Maybe it's because it's something else. Maybe because it's the wall moving. Same thing with loose bricks. So when you're looking around that, so when you're looking on the exterior of the house and you see those two different types of conditions, don't just note the damaged or the missing mortar or the loose brick. Stand a little bit further away. Make sure that wall or the wall next to it, if you're next to a corner, make sure it's not moving. Make sure it's not leaning. Make sure it's not a bigger condition that's actually creating the smaller condition that you saw. Because a smaller condition that you saw with a leaning or a moving wall, all of a sudden it's, oh wait, that's actually that actually could be a pretty large condition. So we talked about the misdirected downspouts. We want to make sure, right, water's daylighting away from the home. Overflowing gutters. Make sure that the gutters are always free of debris, not clogged. That's why we always say it's always a great idea. Well, it's good to be able to inspect a home while it's raining or just after a rainfall, right? Because we want to make sure that those gutters are able to do their job, directing water away from the home. We don't want standing water anywhere around the house. Not great. Horizontal cracks, naturally, we want to know where those cracks. We want to know if there are horizontal cracks. If there are horizontal cracks that we discover inside the house in the basement, most of the time if you see the horizontal crack, you want to go back to the outside and see if the grading is flat or negative or negative. Where on the opposite end of that wall where you saw the horizontal crack, because how does horizontal cracks typically happen? Comes from what? Pushing on the foundation. That's what we call hydrostatic pressure. The foundations are predominantly taking vertical loads, right? Not horizontal loads, which is the reason why they're susceptible to hydrostatic pressure. But then if you see that horizontal crack, you want to take note, is this wall also moving? That's very important to know and bring to the family's attention. So not only did I see or observe, because we're observing, not only did I observe this horizontal crack, but with the horizontal crack, I also observed that the wall was moving. So it's not just a minor crack. The wall was actually leaning. Vertical cracks and step cracks are things that you want to note. Now, remember, not all cracks are necessarily a structural crack, right? Concrete cracks, that's just what it does. But we need to make sure that we identify and bring to the families or the client's attention where these cracks are located. Is it our job again to determine why the crack, why there's a crack here? No, but as we become more seasoned, or because we are seasoned, we're able to help better assess and determine what the possible cause is. So if we were to see a crack, let's say for example, that is less than a quarter of an inch in width, you would probably, without any movement, most people would agree that that is not a structural concern. However, if the crack transitions all the way through the wall, and it's hard to know, but it's important to also put that into your report, that if the crack transitions all the way through the wall, then it can allow water to transition into the home, even though this crack is not large, less than a quarter of an inch in width. I've actually seen cracks. I've actually seen cracks that are an eighth of an inch that allow water to transition through. Now, not foolproof, but where is the greatest probability for cracks to actually transition all the way through the wall? The greatest probability where cracks are able to transition all the way through the wall are in weak points in the foundation. Weak points in the foundation would be things like large openings, windows, doors, beam pockets. Those are openings in the foundation where that can happen. So when we're inspecting a resale where the basement's completely finished, how are we going to know if that crack is transitioning all the way through the wall? And the only thing that we can do is just inform the client and say, just so you are aware, I can't see the other side, so just keep an eye out. The carpet's not wet today. The bottom part of the drywall is not wet today. The wall is not showing moisture stains. My thermal imaging camera is not showing any anomalies here. My moisture meter is not picking up a high moisture retention reading. But just know I can't see through this wall, and it may or may not be transitioning through. But then also, if that crack was coming from the large opening, so window or door or beam pocket, then I would suggest adding another sentence that says this crack is located in a weak point in the foundation where there is a higher probability for this to transition through. And the only way to know is to remove that wall on the other side, the drywall or the insulation itself. Um, let's see here. Untreated wood, we talked about that before. Previous repairs, um, not previous repairs. I think all of us have come across interesting previous repairs. So whenever you see a previous repair, you want to look around that area and try to determine, oh, why was this repaired in the past? What was the condition, or what was the event that necessitated that particular repair, and do your best to see if they did a good job with the repair itself, or do they just put a band-aid over it and then never actually fix the cause? Because that's not going to work long term, right? Sagging lintels. So if you've got a large opening around, let's say, a window, or a garage or a door, and they've got, let's say, like full beds, like a full bed of stone, that's just very, very heavy. If you see it sagging naturally, that's not great, because it's helping to transfer the load around that large opening. Missing or obstructed weep holes. Weep holes are meant to help drain the water out from behind the wall, try to keep everything as dry as possible. Sometimes you'll see homes where the family or the seller didn't understand what a weep hole is, didn't understand that it's meant to be open, and then they'll seal it, thinking that it's just an opening in the home, and it could possibly create additional concerns there. Another one that's seen all the time, missing or improperly installed flashing. Flashing helps to prevent water from transitioning into the home, right? Nothing ever is waterproof. Nothing is ever is waterproof. Even a properly flashed, properly installed roof in the right conditions can allow water to transition into the home. So very, very, very important to make sure that flashing is in place, anywhere where you've got an opening, you've got an intersection, and make sure to the best of your ability that it's installed correctly. AJ, can we move on to the next slide? Vertical cracks in poured concrete foundation walls. Okay, so cracks in poured concrete foundation walls. So a vertical foundation crack, it could be due to could not could be due to a serious settlement, if it is significantly large or shows signs of ongoing movements. If the so let's stop there for a second. So movements, so movement meaning like leaning, right? Leaning, or the actual wall itself, either the right or the left side of the crack is either moving inwards towards the home or towards you, to the exterior of the home. We call that plane displacement. If the cause is a shrinkage, a shrinkage crack, less of a concern, as opposed to settlement, because as we discussed, concrete cracks. It's just what it does. We just need to be cognizant of how large is the crack, where's that crack centered and located, but then also what are the conditions around the crack that might actually describe why it's there. So vertical cracks, they're not typically known to be caused by frost. So frost, frozen dirt, that's up against the foundation. So diagonal cracks that grow in width, especially ones that are wider at the bottom than at the top, those are going to indicate settlement. So diagonal cracks over windows could indicate a weak header. Diagonal cracks in a poor concrete foundation that are fairly uniform in width, or like a hairline type caused by shrinkage, are typically not, as discussed, are typically not structural defects, even though they could allow water to transition it into the home. A crack that forms a V shape, so a V shaped crack, um, may indicate heaving. So that's where like the ground starts to move upwards. In the illustration here, so top left diagram there, you can see that the crack, it shows a V shape opening or crack in the foundation wall, indicating heaving. So that upward movement of the soil from the ground. So let's see here. The ground in the illustration that's expanding. So the bottom right corner, that one, you can see that it's moving in the opposite direction there. So both are interesting cracks, structural concerns, and need to be further evaluated by a foundation contractor for sure. Um, let's see here. Any questions? Any questions? Any questions?
No questions as of yet.
Okay. So heaving. Since we were just talking about that, so heaving. Sometimes you may actually encounter heaving on the basement floor. You may also encounter heaving in the garage. So just know that whenever you see unevenness in either of these locations, are typically not a concern, because the basement floor, the garage floor, it's going to be independent of the foundation walls, right? It may still not be desirable to the family or to the client that you're helping, but it's typically not going to be a structural concern, because it's just independent. It's just independent of the foundation walls. Okay. AJ, can we move on to decks and porches, please? So for decks and porches, very important to also take your time for decks and porches. Um, almost I would say I'd probably say every single deck or porch that I've been on has always had something on it. Incredibly important to make sure that you're noting as much as you can, and bring to the family's attention what the condition of the deck is in. I would say I would say walking surfaces for a deck typically can last up to 20 years. Support systems for a deck, if it's made out of wood. Support systems for deck can last up to around 30 years or so. And then need to be replaced. Remember, the system is outside. It's wood based, right? Naturally. So it just has a lot of wear and tear. Oftentimes, the different parts or sections of a decking or a porch system that are going to be in need of further evaluation, repair, care, are going to be the connections, the connective parts of the deck. Here you can see on the slides, or on this particular slide, missing or loose fasteners, whether it be bolts, their nuts, whether it be the deck hangers themselves, maybe they're missing nails, maybe those nails are loose, maybe those nails aren't driven at a diagonal angle. You'll see. I know we all come across when we're looking at hangers. Not only do they have face nails, right, the left and right side of the face of the hanger, they also have shear nails. It's a diagonal nailing pattern that also helps to increase the strength of the overall system. But also remember, I said diagonal. It's a diagonal nailing patterns system there. And the manufacturer, the more popular ones, Mytech or Simpson Strong Tie. So they design these shear nail openings in such a way. Simpson Strong Tie calls it a predetermined dimple pattern to be installed diagonally. And sometimes you'll actually see a contractor actually installing the what's supposed to be a shear diagonal nail sideways as opposed to diagonal, and then into the carrying or the supporting framing, depending on who you're on who the manufacturer is. I believe Simpson Strong Tie calls the two pieces of framing carrying and carried members, and then MyTech will call them supporting and supported. So supported members, a little nuance, but they describe it a little bit differently there. But also, it's important to know is this wood? Is this treated wood? Is this treated wood? Are we using the right wood here to make sure that it lasts a long time? Sometimes you'll come across and see that that it is not treated wood. Important to know the condition of how the home is protecting the wood. Are we painting this? Are we staining this? Is the paint damaged, worn, faded? Same thing with the stain, because then the wood is going to be exposed to moisture. Is the deck important to if you think it's for the deck, is the deck pulling away from the house itself? The ledger board is helping to support the decking system. That's that horizontal piece of framing that attaches to the home itself. So are there lag screws into that ledger board? Are there anchor bolts into that ledger board? The other important thing is, so if you're standing on the deck, I know sometimes it's, oh, why are we doing it? But every once in a while, I actually come across it where I will stand like in the center of the deck and I will try to rock myself back and forth with my feet. And every once in a while, I'll actually see the entire decking system rock back and forth with me, rack back and forth with me. Not great. So very important to know that the deck is ready to use, or if it does need a little bit of care before but before we're ready to use it again. One of the other things that I see that we wouldn't be able to see on a resale because we've got the drywall up in the house already, but what you might be able to see when you do a pre-drywall inspection is when they are so when the builder and their subcontractor, their vendor, is installing the ledger board to the house. One, we want to make sure it's like directly attached to the house, right? So we don't want it attached to the siding, that can make the ledger board move. We want it attached to a solid surface, but then also note that I said solid. If you can see if you see a ledger board there, go inside the house and make sure that the bolts are actually being driven into something solid and not just the OSB band board that wraps around the bottom part of the house, because you will see it happen from time to time if you will now just to start looking for it, because it's important. I've seen it periodically from time to time over the years where the subcontractor will literally attach the ledger board to the house, bolt it through the ledger board onto the OSB sheathing, but then nothing else. And then when you go inside the house, you'll actually see the other end of the bolt, and it's actually not going into framing. I saw that one time, and I remember hearing the response back from the builder through the client, and the builder had actually commented and said, I actually lost sleep over that. The fact that we were ready to go and hang up the drywall, and Phil found that those I think there were the lag bolts were actually being bolted into something solid like a deck. Happens. Let's see here. AJ, can we move on to the roof slide, please? So from a roofing standpoint, and this is something that that you want to use from a far away perspective, is you want to try to get a sense of what the structure is like initially from the roofing system. So that way, when you enter, if you think it's safe and you're looking in the attic and then you're entering in the attic, you know where to best spend your spend your time. So you want to look for things like sagging rafters, sagging roof sheathing between the rafters, sagging a sagging ridge, or a roof that's actually spreading apart, and you wouldn't be able to really get a good sense of what's happening unless you stand further away. But standing further away from the house to take a like a macro perspective in terms of what's happening, you can only do that when you take your time, right? So very, very, very important because that whole entire system is being held up either with rafters or the actual trusses themselves. So which is also the reason why there are tolerances. That question that we got earlier, where the web framing would look like it was gapping or pulling away from the top core of the truss. There's a reason why there are tolerances. Eighth of an inch, 16th of an inch, for those pieces of framing, because we want to try to prevent those things from happening. If you see, if you know the house was built during a certain time period and it's going to have a rafter system, and you see some roof spreading, or see something sagging, you know instantly in the back of your mind what should you be looking for when you either peek your head into the attic or you step into the attic. Where are my collar ties? Do I have collar ties? Are there collar ties in between in between every single rafter system? Are the collar ties damaged? Are they secured? Are they rotted? So those are the different. So that's why it's important to look far away, but then also look close up, to try to give yourself multiple perspectives in terms of what's actually what's actually happening. AJ, can we move on to roof structure in attic? If we have time towards the end, we'll be able we'll watch the video with Ben inspecting the exterior.
Yeah, we do have one question though, while we're
Yeah,
on the topic. How can you tell if a roof is spreading?
you kind of you're gonna have to. So when you look far away, um, trying to the easiest way to describe this, because all the roofs are going to have are going to have different pitches, right? So if you start to see instances where the roof looks a lot flatter than it probably should, for the size of the house, that's going to be spreading. If you see like the ridge, and you're only going to be able to get this sense when you've already done the whole like 360 around the house. So probably your first look on one elevation, so one side of the house, you're probably not going to be able to deduce that. It's going to be after you go around the entire home. If you think that the ridge is starting to like sag like low, like the whole entire thing like is a little low and just seems off, that's going to be an indication. But you're only going to be able to really conclude that the roof is actually spreading. So when you go into the attic, or if you peek into the attic, if you start to see gaps in between the rafter and then the ridge beam, and the gap and there are a whole bunch of gaps in between the bottom part of that rafter system and the beam, you know that's spreading. There are times where there isn't a collar tie holding each rafter system together. There are times where the collar tie is damaged. It's where it's just rotted, and that could explain it. So it does happen. I would say I don't see it really all that often, but every once in a while I've actually seen it on a front cover for a listing photo, or from something else where somebody had posted something on a social media platform, and you can just see the sag, right from the ridge. So that's the reason why I think it's so important to take your time and really get a good sense of what the overall structure is doing. And again, it's also a little bit of your intuition. If something looks off, then look at it a little bit more closely. The one structural engineer friend that I know, and also has helped to shape my opinion in terms of my knowledge level and what to look for and what are the things that typically stand out to him when he's being called in after the home inspection has been done, or when a family is just directly calling the structural engineer because of things that they've discovered in the home that they had concerns on. Is a lot of the things that is just very, very obvious and easy to my structural engineer friend, home inspectors miss. So think about what I just said. Things that are very, very easy and obvious to my friend, the structural engineer, where he didn't even really dig in all that much yet. He just pulled up to the house. The home inspector missed. And I think it all goes back to when we first started our webinar and started learning together. It's because we're trying to accommodate the volume, which is which is a good problem to have. We're trying to accommodate the volume, but we're doing it in such a way where it's starting to compromise our ability to be able to just be able to identify, observe, and note just easy defects. Easy defects. AJ, any other questions?
Should collar ties be on every rafter? Where is the best place for these to be heightened wise off? To be heightened
Yeah,
wise the attic floor.
good question. So this is coming from my structural engineer. The best practice is to put the collar ties on. Just put the collar ties on. If you see a collar, if you see that it doesn't have a collar tie, just put it in your report and say, at the time of the inspection, I observed a missing collar tie here. It's important to have collar ties. It'll help hold the roof framing system together. The collar ties are typically going to be in the upper quarter of the rafter system. So I don't think I've ever seen one instance where I had a question about a roof rafter system. I take a video, I take a picture, and send it to my structural engineer friend, and he says, "Phil, you don't need collar ties there."
Can you talk a little bit on seasonal truss uplift on interior non-load bearing walls?
So seasonal truss uplift. So for those of you that aren't familiar with truss uplift, okay, so that's a really good question, by the way. Okay, so truss uplift. So that's where you've got the trusses actually lifting upwards due to the different temperatures that are actually in the attic in the attic itself. AJ, what was the other part of the question? I'm sorry. Talk about the seasonal truss uplift.
Let me find it.
Sorry.
Um, on interior non-load bearing walls.
So the big thing was seasonal truss uplift is, I would say, from a new construction standpoint, is that it is an undesirable condition because it's essentially creating what the builder would just default describe as settlement cracking in between the ceiling and wall. And unless the builder did a really, really good job at trying to control the actual truss uplift condition, then repairing the drywall in the ceiling and the wall connection, it's always going to come back what looks to be settlement cracking. So truss uplift, I would say I typically don't see it all that often, just because the builder is trying to do a really good job at controlling the temperature differences for the home itself. So one of the things that they're doing is they're trying to insulate the home. They're trying to insulate the home. So that's where they're putting insulation into the attic, and then they're also putting insulation into the walls. They're also trying to use that spray foam that we talked about earlier, which is called fire block, to try to prevent the try to prevent airflow from traveling from one floor to the next floor to actually create that temperature difference. We do now have soffits to try to keep the temperature in the attic as cool as possible. There are baffles up there now that are typically made out of just cardboard to also help prevent the soffit holes from being blocked. But every once in a while, we will hear about truss uplift. But from a commonality standpoint, how often we would actually see truss uplift? Not that much. It's a very good question.
And should collar ties be the same size as roof rafters, i.e., 2x8s?
I don't know the actual. I'm not 100% sure off the top of my head, but my inclination would be yes.
All right, and this is a good question to lead in to the next slide. Should there be a double upper plate in your diagram?
Which hold on one second. In that diet, let me see. I would put a double, but those are rafters. So if I were to build that home, I would probably be putting a double top plate on top. But also remember, the only way to know for sure if this needs a double top plate is to check the plan details of the builder to see if it's truly required. Because again, remember they're doing load calculations. They're doing load calculations, and not they're doing calculations not just on the size, on the dimensions of the rafters, but they're also doing load calculations based off of the species of the wood and how long the rafters are. So maybe based off of a certain design, maybe the designers of the house, if let's say that let's just pretend that this is an actual that this is actually part of the blueprint for the house that you're inspecting. Maybe they already signed off on it and said yes, based off of how we actually designed this house, so on and so forth. I don't need a double top plate here. But one of the things that I always say is when in doubt, call it out. Runs. When in doubt, call it out. And just say, hey, so I typically see a double top plate installed here. Recommend to ask a builder to check their plan details to see if they need one. Good question.
That's all the questions we have.
Awesome. Okay. So the other one that's also important I think it's just important to talk about really quickly is oh, hold on one second. Is see in the center picture there towards the middle, you'll see some water standing on the roof. There, this is more of like a roofing condition, not a structural, but it is important to know as much as you can. Try to make sure that all openings are properly flashed, right? So I see a PVC pipe there. So I am expecting to make sure to see a pipe boot on the roof. Expecting to see nails that are actually being sealed. I'm hoping to not see that the top of the boot has collapsed inwards, so it is concaved. That it's not concave versus convex. If it has collapsed inward, so concave, it's harder for water to drain out, which means could explain the reason why the water, the water staying there. Maybe these pipe boots typically last on paper. Let's call it maybe like 8 to 10 years. Maybe that boot is really old. And it's torn or it has an open hole, and maybe that's the reason why water is transitioning through. But whenever there's an opening, we need to make sure that we do an amazing job flashing it out, and any type of fastener that we're using to fasten that particular system to the roof, make sure it's always sealed with a nail. Okay. Um, let's see here. AJ, can we move into basements and crawl spaces? Okay, so the right illustration there, you can see the diagonal crack on the foundation wall, and then you can see the illustrator's depiction of water staining. I think it's just incredibly important to again reiterate, just because the crack is not more than a quarter of an inch in width does not mean that it's not going to allow water to transition through. So if you can see the crack on the inside of the home in the basement, then the recommendation needs to be, I recommend to have the crack sealed to help prevent water from transitioning into the home. Now, remember, if you'll remember, I said quarter of an inch, right? That is typically the general builder tolerance in terms of when is the community required to act. And most of them will follow that guideline. There are some builders that will actually say, actually, because we are a high-end builder, our tolerance is actually not a quarter. It's not a quarter of an inch, Phil. It is actually an eighth of an inch. So if you actually see any type of cracking that is exceeding an eighth of an inch, that is exceeding our performance guideline, and we will seal that crack to better ensure that water is not transitioning into the home. Um, let's see here. All right, AJ, let's can we move on to crawl space construction, please? Okay, so crawl space construction. As you can tell, a lot of what we're reviewing together, there are a lot of commonalities, regardless of whether or not it's a basement structure, it's a slab on grade structure, uh, it's a crawl space structure. Excuse me, because you always want to make sure that to the best of your ability, you're able to control, direct, manage the water and direct it away from the home. So even with a crawl space, you want to check for indications of external forces being applied to the foundation wall itself. So that would essentially be so if it's in the ground, that would be your hydrostatic pressure, right? So there is a dry type of soil that can actually exert a force, so a force onto the foundation wall. That type of soil it's an expansive clay soil. The weight and pressure of a dry soil could actually also crack a foundation. There's a wet soil, so either expansive or a swelling soil that can also do the same thing and exert a force onto that foundation. It's interesting. So when we build, sometimes the builders will install what we call wing walls around the foundation. When we were at a resale, or whenever we're doing a final inspection or an 11-month inspection before the 1-year warranty expires, we're not going to see if there's a wing wall on that foundation, because it's buried underneath the ground, right? But the builder is doing their best to try to minimize the amount of pressure that's going onto the foundation wall, but by installing these separate walls to help relieve some of that pressure. So a wet soil, as we all know, can crack a foundation and then allow moisture to go through. So very, 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 very important to make sure that we're controlling and managing that moisture. So as you can see on the diagram, and we see this in a lot of the different venues or avenues that we use for our learning. So 24-inch minimum from the ground to the bottom of the joist, right? 18-inch minimum from the bottom to the ground to a girder, right? Just because that girder is that main support or that main carry. Just important to be very, very cognizant of proximity of wood materials to the ground.
Is that the same concept for a bulging foundation wall?
Yeah, so it would be the same concept, AJ. Good question for a for a bulging foundation wall, because it's all about again managing that moisture. So if you have a bulging foundation wall and the wall is actually moving inwards into the home or moving, so if you're standing if you're in the basement and the wall seems to be moving towards you, it's because the soil most likely is pushing on that wall itself. And why is the soil pushing on that wall? Most likely, you're going to have either one or a combination. It's usually a combination, several conditions on the outside. Gutters not discharging or daylighting, water far enough away from the home. You have grading that's not falling 6 inches for the first 10 feet. So it's important to, even though extending or daylighting the gutters further away from the house, even though it's a very in practice easy thing to do, right? Because oftentimes for just very, very quickly, you can go to most of the hardware stores and get a gutter extension and attach it. I mean, that's easy, right? It's a pretty nominal cost. But if unchecked and not corrected, a gutter that's daylighting too close to the home will impact the grade. It will change the grade from 6 inches of fall for the first 10 feet to flat to negative, where that grade is directing all the water or a lot of the water towards that foundation wall and then pushing on it and then creating that bulging wall. AJ, I'm seeing a question from Adam Wood that I can read for everybody.
Okay.
So Adam made the comment. So we haven't talked about it yet, but might be coming up. But we can talk about it now. So here in coastal Virginia, we have an issue with high humidity and mold in crawl spaces. Do you have a best recommendation on dealing with humidity, assuming proper vapor barrier, ventilation, gutters, and grading? Uh, Thanks for the question, Adam. Uh, so I come across the same thing too. When I see when I see crawl spaces. Um, One, you want to like you mentioned, you want to have ventilation. The only other thing that I've seen contractors do to try to dry out the space, maybe consider if it's even feasible, dehumidifiers. Maybe a dehumidifier. If there's a sump pump system in located inside that crawl space, then daylight the water into the crock, fancy term for it called for a well, and then just pump the water out. But obviously, you know, I most of the time, I would say 99.9% of the time, I see the water daylighting out of that sump pump drain system right back right back next to the home. I mean, so that's not helping. So you want to make sure that you daylight that water as far away as possible. But yeah, that's an ongoing challenge. I think that that might be one of the reasons why a lot of builders just choose not to do crawl spaces unless they have to.
All right. Let's see. We got some questions in the Q&A. Tom asks, what about the causes of a basement wall leaning outward?
A basement wall leaning outward. I don't think I have ever actually seen a basement wall leaning outward. But if you would think about why would a basement wall be leaning outward, you would have to immediately think about what is that footer like, right? So the footer has to extend past the face of the foundation, right? I believe it's 2 feet typically past the foundation wall itself or the face. So then the question becomes if it's leaning, what is the grading system like, and what is the gutter system like? Why is that thing moving? And oftentimes it's moving because the soil is too soft, and the soil is too soft for a reason. Most of the time it's because of the moisture management.
Bottom
So
plates.
also I guess, oh, sorry AJ, so if the wall is leaning, so then I think the natural next question becomes, is the wall actually affecting the house? um Now, it's not our job to say definitively yes, definitively no. But we mentally take a note of that. And then when we're inside the home, check the floors, right? Check the floors, check the windows, check the doors. Are the windows easy to open and close? Are there is there any type of cracking around the tops of the corners of those windows? Same thing for the doors. Take a look at the drywall for the ceilings and for the walls. Do we have any movement? Do we have any cracking? It's you want to see if that one condition is potentially impacting others, and then if you do see that it's also impacting other systems in the home, then you would tie it into into one section that says, hey, so at the time of the inspection, I observed that the wall was leaning to the left or leaning to the right. While I was inside the home, I also observed cracking on the ceiling and the wall connection. I also observed that the window pane glass was cracked here in the same location. The window was also hard to open, and the floor was a little low. Recommend to have a foundation and structural engineer further evaluate the entire support structure system for the home and repair or replace as needed.
All right. Bottom plates overhang the foundation. I have been trying to find in the IRC code whether there is a tolerance about these non-fully supported conditions. Could you please comment about it?
Very good question. I have never had to actually look that up to see what the tolerance would be, to see how much would actually be allowed to overhang. Um, I know the NAHB performance guideline also doesn't. The NAHB performance guideline isn't the end all be all, but it does have a lot of good stuff. I haven't seen any references to overhanging bottom sill plates. Um, I will say that I did one time see a bottom sill plate that wasn't square, and it must have been off by at least a good 3/4 of an inch. And of course, it was on a $4 million full custom house. And the builder was very quick to fix it for what it's worth.
Phil, I keep running into the same issue on new builds and 11-month warranty inspections. Builders are skipping the right head flashing above windows and relying on flashing tape, saying it meets code, but most major manufacturers, I'm not going to say, still call for rigid dip caps and mechanical ways to shed boat water. Do you
Yeah,
recommend adding a drip cap, or is flashing tape sufficient? How do you approach this and your inspections on new builds specifically? Thanks.
yeah, that's a great question. Okay, so we have to do, and AJ, remind me. So without saying the manufacturer does recommend to have it there. The client,
Call for a rigid drip cap as the mechanical way to shed bulk water.
okay, okay, all right. So I'll answer it in a couple different ways. So my first response to that is there's a million and one different ways to build a house, right? Building a house is part of a science, and it's also part of an art form too. There's a whole bunch of different ways that we can actually build this thing from the ground up. Um, we want to do our best to try to minimize. I'm not saying that this is a wish list because it's not, because apparently you've already researched and the actual manufacturer wants it. But we want to do our best to try to minimize what I call, and this might be a little too harsh, but what I call wish list or preferences in terms of how we would like to see things done. Because the more preference items that we note in the report, or wish listy items, as I call it in the report, the more resistant the builder becomes. We want to stick to the bare minimum. It's sad, but we want to stick to the bare minimum of what the builder is required to do. Because I know builders, they've told me point blank, they will literally look at the first five things on a home inspector's report. And if they determine that that home inspector does not know what he or she is doing, they will literally take that report and pitch it in the trash. Because are the builders required to do what you and I say? No. They're only required what their plan details direct them to do. So that could be from the architect, that could be from the blueprints, the drawings for the house. That could be from the plan details from the actual from Huber, or if they want a drip cap on the actual top to help prevent bulk water from transitioning into the home. So for those of you who don't know, bulk water is just a fancy way to say a lot of water from transitioning into the home. Then they're not going to do it because also the other reason why they say we build to our plan details and that's it. Now, we're not saying that what you're saying is not a good idea. We're doing what the manufacturer wanted or what our plan details wanted, because what could end up happening is if they start building better, then what could end up happening, I know it's sad, but what could end up happening is, well, the community will hear about, oh, well, they treated house A really nicely. They did all these different things for house A. What about house B? What about house C? And then all of a sudden it just snowballs, and now they're doing it for the whole entire neighborhood. Or what if they forget to do it for house C, but they did it for A and B? But it's a greater chance for them to forget to do it for house C because it was never part of the plan detail. But then what if for some reason they do something that is not on the plan detail, but because they did something that wasn't on the plan detail, that something now impacted something else in the house. And then now and now they're having to deal with it in warranty because they did something to the house that wasn't on the plan detail, and now it's perceived to be impacting the house. So now the project manager is on the hook. So that's the reason why you'll always hear the builder say, I'm not required to do anything that your home inspector says. I'm only required to let him or her in. If they show me something that is exceeding our minimum performance guideline, or is not up to code, even though we're not code inspectors, it's not up to code, then I will act. But that's the reason why you will actually see them say that. But if you have something roundabout way to answer your question, but if you have something from that manufacturer and the manufacturer specifically says, I need you to install it in this way, and the builder did not install it in that way, then yes, stand your ground, bring it to the builder's attention and say, hey, I think you really need to take a look at this because per the manufacturer directions here, per their plan details, it says you have to install it in this way, and it's not installed in this way. Now, also the last thing I'll comment on that is that we will absolutely hear from the builders. Well, this already passed inspection. This is fine. It is ready. It's ready to use. Just because something passed inspection doesn't mean that it's actually good to go. It just means that whatever that municipality inspector was looking at was good to go. Doesn't mean the entire system was good to go. It just means whatever they were looking at was good to go. It's a huge difference. Huge, 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 huge difference. Actually, I'll give you one more example because you all know I'm full of examples. Okay, so this was last winter. I think this was last winter. Okay, so I'll try to make this quick. So I was doing a pre-drywall inspection, and I got there very early in the morning, before the project manager and the city inspector were there. So I had already looked. I had already looked at the attic system on the second floor, and I had already looked at the attic system in the garage. So I already knew what the condition was like. They were loose gusset plates. Shocker. Um, Fun fact: any gusset plate, so metal connector plate that holds the truss framing system together, any metal connector plate that has an embedment gap. That's a fancy term for loose. Any metal connector plate that has an embedment gap that exceeds 1/32 of an inch, then I know it's really tiny, but that's what they say, TPI. It should be shown, that condition should be shown to the builder's truss fabricator and determine if a repair is needed. And if so, what is a prescription? I saw a very loose, not trivially loose, a very loose gusset plate in the garage to the point where it's just like barely hanging on. So fast forward, the city inspector had already signed off on the house, said, amazing, this is amazing, good to go. So that person already walked out. Project manager was still in the house. So then at one point, I ran into the project manager and he was walking out through the garage. And I said, hey, he said, hey, what's up, Phil? And I said, hey, so I just want to let you know That way you don't lose time on it, because I also want to show that I'm sensitive, that they have. The more that we can demonstrate that we're sensitive to what their environment is like, the more likely they are to actually do what we need them to do. So I said, hey, so I know that you're trying to hang the drywall soon, and I don't want you to wait for this report to come out. You have a loose gusset plate here, in the attic, in this particular section over here. Um, and then I'll never forget it, because it was just crazy, but just confirmed what I always knew. He looked at it, and then he's just sighing. He said, Bill, the inspector also saw it, and the inspector said that it was fine. It's going to be, this is like crazy loose. He said the inspector said it was fine, and passed me anyways. And then I looked at him and I said, what? And then the project manager then again sighed and said, you know what? You're right. You're right. You're right. You're right. I'll call out for the certification. I'll call out for the structural cert. It typically, depending on who the builder is, maybe like a couple days. I'll call out for the structural cert. I'll get it repaired. I'll get it repaired. The house passed the inspection. The inspector saw the condition. The project manager told me that the inspector saw the condition. It still passed the house. So, moral of the story is, just because the house passed the inspection does not mean that every single system in that house is good to go. We all know that. It is our job, as the inspector community, to advocate for the families, because they will not know nearly as much as we do. So, sorry. Okay. So we've been talking about this. I would say almost ad nauseum, but it's incredibly important to, again, make sure that we're controlling, managing the moisture, and directing the water as far away from the home as possible. So the two big takeaways, for the diagram here, is one, on the left, you can see how water, if the grade is flat, water will sit around the foundation, and eventually at some point it's going to get absorbed by the wall, and then it's going to travel upwards, which is called capillary action. And look what it's doing. It's going to come in contact with that floor framing that's made out of wood. So, and again, it's impossible to know, especially if we're at a finished home. Is there a sill sealer on that bottom plate? I don't know, but if you're doing a pre-drywall inspection, you better do your best to make sure that there's a sill sealer there. Um, and then also the other thing too, that I've actually noticed, digressing, since we're talking about capillary action moving upwards, if you're seeing so if you're at a resale where you're fortunate enough to see a girder, so big beam, right, that's made out of wood, and it's resting in a beam pocket, just make sure that there is some type of capillary break, in between that wood girder beam, and the actual concrete beam pocket, right? Oftentimes builders will just wrap that in some type of flashing tape there to act as the capillary break. Diagrams to the right, naturally you can see how gutter daylighting way too close, and then at some point the water is going to start to flow towards the foundation, and the water is going to transition inwards. But then you could go, someone could say, but Phil, isn't there a drain tile right there? The image is depicting a drain tile there. The drain tile is going to collect the water, right? The drain tile is going to collect the water. That's what it's supposed to do, and it's going to direct it into the sump pump, into the well, into the crock, and then the sump pump system's going to take care of it. How long is a sump pump system supposed to last for on average? Like 8 to 10 years. So we don't want to wear out the system. So very, very important to make sure all these different systems are working together, to try to protect the home, and make sure it lasts. It lasts as long as possible. AJ, next slide, please. So a little bit of the same, a little redundant, but again, you can see what can actually happen if the grade is not ideal. On the bottom left diagram there, over time, hydrostatic pressure, so that's soil pushing on the foundation, and then that's when you're going to see that bowing, which also may also describe why that wall is leaning. If there's drywall on the inside of that of the basement, you may not see the crack. The framing may actually hide the fact that the wall is bowing, but the indicator would be that the wall is leaning to the left or leaning to the right, depending on how you're actually facing, depending on how you're facing the home. So, interesting fact: water. So water is dense, and weighs about 60 pounds per cubic foot. Isn't that interesting? 60 pounds per cubic foot. And that's why it's so important, because then it's going to create an immense amount of pressure along with the grade itself, and push on that wall. So the other one that I think is also worth noting, if you're inside the basement, if you're inside the basement and it's unfinished area, if you see spalling, on the actual wall itself, so flaking, that's a sign, that there might be water or moisture hanging around the exterior of the home and the foundation. And if you didn't see any signs and note that initially on your initial walk the exterior, go back outside, because there's most likely going to be a condition that explains the reason why there's spalling there. We gotta direct the water away, and it's not being directed away enough. Efflorescence, that's that white powdery substance, right? That's on the different types of building materials. Efflorescence itself is not a structural concern, but it is a reminder that the water is being absorbed by that building material there. So again, handy reminder. Hey, so I see the efflorescence. Do I see any other conditions that tie to this particular condition that would describe why I'm seeing it on the wall, and just make sure that it's not excessive. AJ, crawl space slide. I think these are pretty funny. Naturally, any type of support there. Let's make these permanent. Let's make these permanent supports, and the connection there, as opposed to just sticking with a tree branch or a tree trunk there. I actually came across it once. Gosh, this might have been 4 years ago. I kid you all not. I was in it was in the country, and it was a garage. I kid you not. There were literally there. It must have been like four. So it was 2 rows of tree trunks that were cut to size, and those were the actual support posts in the garage. It's crazy. It's crazy. I think I wrote. I think I wrote it up as a not permanent. I think the header for in that report was not permanent dash connection. So I mean, that stuff's obvious. Um, AJ, next slide. Here, so concrete masonry units, CMUs, hollow channels. Remember, you want them to be vertical. You want them to be vertical, as opposed to horizontal. If they're not horizontal, it's not great. Yeah, not great. Great. Let's see here. What time do we have? Because I do want to get to the video of the structural engineer, that's going through the house. Because I think that one is really good to watch. AJ, perfect.
Well, I would say the first thing that we notice when we come take a look at a house is going to be the overall grading and the landscaping of it, and that's going to be with this one. It's pretty obvious they cut back into a hill, and the original hill that was here, so we're going to have a lot of water and moisture coming down to the back of the house, and it also kind of makes you wonder what they did with the rest of that soil and the backfill when they brought it in. So it would make me believe that a lot of it was probably placed up here to level out the front. So I think we're going to, we can see that there's definitely going to be movement out of the house just looking at it initially, but I think a lot of that's going to be caused by the soil and the scenario that the house was built in with the cutaway up the hill. So first thing we're going to notice kind of walking up to the outside is going to be the cracking and everything else that's not only in the stucco but also in the pillars. You can see we have some compression cracking here, some separation where this is actually settled away a little bit. This house we're actually going to see some settlement and heaving, just both different signs of some vertical movement that we're running into. You can see all of these pillars here kind of have similar issues to where they're getting that vertical movement. Things to look for in vertical movement is going to be the difference between upward pressure and subsidence or settling. Over here, if you can see it, we're actually getting some signs of some upward pressure or some heaving, and you can see that instead of having that separation cracking, we're actually getting this as it's pushing together, and it's called a compression crack. So you look for the compression cracking or the separation will tell you which way the house is moving. So coming around to the front, we see, again, some separation cracking of the porch. This is suggesting that the front porch is obviously going to be working its way kind of down the hill, which is making sense, again, kind of talking about when they first initially dug this house out, they probably put a lot of their backfill and their soil that they dug out of the hill out to level out this front, which is going to be now loosely compacted soil, which is going to be causing this settlement. If you come around the front side of these steps, you can see a lot of breaking and cracking through the overall finish work of it, and you can see quite a bit of separation, which when this was originally built would have been done basically all put together. You're obviously not going to leave large cracking, so we know that this whole front part is basically working its way down the hill. Moving up to these columns, which if done correctly should have been put on top of caissons. Probably not the case in this situation. As we look up, there's a lot of cracking at the points of these, suggesting that these are also settling obviously along with the porch, which would indicate again that they're not necessarily set on caissons. They're most likely just set on this front porch slab that was put in here, which is going to be causing this whole front to sag, and it's actually going to cause stress to the main part of the house as it pulls away from the house. Working our way around, you can actually see again separation cracking here between this initial column and the stairs here, again indicating that it's most likely not set on a caisson, that it was just set on this slab. Ideally, you want to have all of your support columns and pillars set on caissons if the soils engineer is calling for caissons. In this case, it definitely was not built that way. Again, just some more settlement, separation cracking. You can see here with these columns here just how much the soil has basically worked away and settled away, and so that's going to be another sign that the soil conditions in the area are not necessarily ideal, whether it's because of loose backfill or whether it's just because we're on a hill and things are sloping away and now the added load on here. But these are all just kind of signs to look for that are basically suggesting that the soil conditions are not ideal and that we're going to end up experiencing some sort of movement with the rest of the house as well. So kind of to follow up, you see where the soil's settled away. These are actually be set on caissons, but you can see how much the soil has dropped, and you can see how much just in this column right here, this is actually settled away, and you've got a pretty good sized separation crack, which is causing separation in the overall porch that's hanging on there. So, you know, the soil moving around right around the base of these pillars is obviously going to be a sign to look for something else, and then we come around just a little bit farther around the back and see some serious separation in the next column. And you can also see up at the top of this one, which we can probably get a better shot up on the deck, but just how much damage has been done to just this overall column here due to this movement, which again is going to be putting a lot of stress not only on the roof but on the porch and the rest of the house. Foundation this is set on. Each one of these will be set on a caisson as well, which, you know, the reason that's done that is to get below this active soil region, but it's obviously not, they didn't do them deep enough, or they didn't get out of the active soil region to an inactive region with as much movement as we're seeing. But it's still very much a sign of how much the soil is moving around, just how much the soil has dropped away. So interior on this, there will actually be the center column here, and there will be a caisson that's working its way all the way down to whatever depths the original soils engineer would have recommended. But again, it hasn't seemed to stop the movement that we're seeing. So one thing while we're outside we also generally take a look at is going to be roof lines and roof structures. You can tell if a house is settling or experiencing heaving based on a roof line if it's uneven. Roof movement's not always necessarily completely indicative of foundation movement. A lot of times you can have poor support or inadequate trusses in the roof or the roof structure. But it definitely is a sign. So if we're seeing an uneven roof, if we're seeing a sagging roof, things like that, it's definitely a sign that there may be something else to look for as far as structural movement. So all of this that we're talking about is basically piecing together a puzzle of what's going on with the overall house. So as we see certain compression cracking, as we see certain separation cracking, things like that, if all of that's in line with certain roof movement, then we can kind of start putting that puzzle together, saying that, okay, we know that this side of the house or this side of the house is experiencing certain movement of a certain variety, and then we can go inside and see certain, verify that there's also damage to the inside in those certain areas, and we can make certain judgments about what's exactly going on that side of the house. So we're in the garage now. Obviously, first thing everybody's going to notice in a garage situation is going to be the cracking of the slab. Slab cracks can be a sign of certain structural issues, but slab movement is not necessarily a structural problem. So again, it can be a piece of the puzzle, but slabs are poured very shallow. They're poured very thin, generally 4 inches, and a lot of times nowadays they're not really reinforced with anything. So just because you're getting a lot of movement out of the slab doesn't necessarily indicate that you're having a lot of structural problems, but it's something to look for. And it's also something to keep an eye on is that slab movement affecting the foundation all? Is the slab, has it heaved to the point where water is going to be able to work its way back towards the foundation and be causing certain problems? And that's, in that case, that's when we need to go in and actually do some replacement or some leveling, mud jacking, things like that, as if it's going to be affecting the foundation negatively, if not even right now down the road. But looking forward, we can definitely see some more vertical cracking in the drywall here. This is going to be a sign of some heaving over here along this wall. There's actually multiple points along this wall that you can see it, which is probably indicating at certain caisson locations where we're getting this movement. And then we're also getting a pretty good sized crack right up here in the wall where, we've separated, 1/8 to 1/4 of an inch, where we're seeing that vertical movement and some compression cracking up here as well. So all signs of stuff to look for in drywall. Any kind of cracking, any kind of separation is all going to be signs of foundation movement and shouldn't be ignored. Even small cracks are going to be indicative of some kind of movement, whether it's severe movement, whether it's movement that necessarily needs repairing. That's where we come in and do an overall evaluation of the structure. But anytime you do see any kind of that drywall cracking, it's going to be a sign of some sort of foundation movement. You can also see here where there's enough movement that the actual baseboard is no longer connected. It's been separated off because of how much everything is kind of moved around. All signs that there's, we know that this whole back wall is going to be moving around. So as we're kind of going in the house, you see some more slab movement here. Obviously, some definite heaving. This slab was actually built with a rise at the edge of it to kind of meet up with the basement floor. But you can see where the slab from the garage is actually pushed up past that and has risen. And again, slab movement's not necessarily a structural issue, but it's something definitely to take a look at and see if it's causing structural issues. And we can talk a little bit more once we get into the basement about basement slab issues and how they can definitely affect the structure of the house. Even if it's not necessarily related to perimeter foundation movement. So we're in the basement now. Again, kind of continuing my slab talk from the garage. One thing to kind of point out is, and this slab does have movement in the basement. We do see some high points and some low points pretty much all around. Again, slab movement is not necessarily indicative of structural issues. However, things to look for are, how are the support columns set? Are they set independently of the slab on their own foundation, or are they just set on top of the slab? If they're set on top of the slab, any slab movement is going to affect that main support column, which then is affecting the structure of the house, affecting the main beam, and affecting the floors above, because everything is lineal, everything is going to be tied together. The other thing to look for is if the basement is finished, if the walls are properly floated. If they're not properly floated, the framing then is going to be just as a direct result of the slab moving around. That's going to be connected to the floor joist, which is then going to be affecting the main floor. So slabs are typically not a structural issue. However, if the framing of the house and the structure of the house wasn't built correctly, it can result in structural issues, and then the slab then becomes a structural problem. What we see over here, this is the front of the house. A lot of times inside you'll see drywall cracking, things like that. This room, we're not really seeing a whole lot of drywall cracking, but what we do see is the walls completely uneven. I'm going to put a level up here. basically showing how uneven this wall is. It's basically bowed out quite a bit, starting roughly right in here. And if we try and level this out, we end up at roughly, and this is a 2-foot level, almost an inch of movement there. So, you know, over the course of the wall, you're talking 3-4 inches that's going to be bowed out and not level. So what's happening is as this wall is getting heaving up, it's actually rotating out as well. So again, you know, when you're looking inside, you're not always going to see just glaring cracks, obvious signs of movement. So you got to kind of look a little bit deeper into what's exactly going on. So here's a good sign of the slab issues we were talking about. You can see here, or maybe you can, hopefully you can see on the camera, there's a ridge going right through the floor here where the slab is heaved up and separated. Now, you know, again, slab movement's not necessarily structural, but if we go to the closest wall here, we see that there's definitely some upward compression on this wall where we're getting cracking now going all the way through the ceiling. So, you know, that's going to lead me to believe that the walls are probably not properly floated, and if they are, that float may have closed up and is now causing pressure up on that framing, which is now causing pressure on the above floor joists, which again is going to cause problems to the upstairs and the overall structure. You can also see coming back through here that this wall is basically, you can see at this door, how it's basically at almost the bottom of a valley if you look at it. And the reason that's going to be there is doors and windows are going to be the weakest points on a foundation. And so that's the first place we look for cracking. That's the first place you're going to see signs of movement. And what we have here, based on this cracking through here, is we probably have some caissons that are heaving up on either side of this door. And because this is a weak point in the foundation, it doesn't have a grade beam, or it doesn't have a foundation wall holding everything in together here, you're going to get a sag between those caissons. Coming back through another room, we notice right in this corner here, quite a bit of cracking and separation. Again, this is going to be a sign of vertical foundation movement. We then kind of travel up and follow this crack. It works its way across this ridge here, and then also up this vent and ductwork line, and we see quite a few nail pops. And you know, people always just kind of ask me and assume that nail pops and cracking is, well, it's just, you know, normal foundation movement. Well, it can be, but when we get to this much movement and this many cracking and this many nail pops, it's going to be a sign that the foundation has moved around, probably to the point past of an allowable tolerance, and that they're going to need some sort of repairs. So we're up on the main floor now, and the first thing we really see that's glaring to me anyways is going to be the large crack that's running up this wall here, over the ceiling, and then back down the adjoining wall. And there's also a high point actually here in the carpet, which I'm sure you probably can't see on camera. But what this is saying is these are going to be more separation cracks, and so it's indicating that we know that the house is at some point separating and moving off. In this case, actually, both sides, but sometimes you'll see those and it's one side of the house is going, but these are definitely caused through separation of a house basically working against itself and working away from itself. We can also see some settlement cracks and some movement right up here above this main archway. That's, you know, basically indicating that, again, the house is experiencing that vertical movement. So what that's going to say to me is that with this crack going right down the middle, is that each side is basically separating, and we're getting some settlement out of the interior, as well as the heaving on the perimeter, and we're probably going to end up getting some more over on this side of the house as well. Working into another side room, first thing I notice in here is there's a main bulge kind of in the floor, and actually looking at it, it almost runs straight up to that wall, and you can kind of see along the baseboard where there's a high point. Looking at it, this is actually above the garage, and there's a main column that's actually set in the garage right below this. So that's either saying that those garage columns were not necessarily set on independent foundations and are kind of moving along with that slab movement, or it's saying that the caissons, or that the pillar is set on, is also heaving up, what we call a deep heave. Which what we're seeing around the perimeter of the house, I would assume they probably have it set on its independent caisson, and just because we're getting a lot of vertical movement out of those caissons around the perimeter, it's not uncommon on an interior caisson to get that same kind of movement. But coming through here, we're also seeing just more signs of vertical movement. You can see cracking in the walls here above the windows. Again, windows and doors are the weakest points of a foundation. It's going to be the first place to look. So we've got some cracking through this window right here, indicating that vertical movement, as well as just a straight vertical crack through this corner right here. And then just basically all around this room is really showing signs of, yeah, that separation crack that we saw in the middle is affecting this side of the house, and we know that it's already affecting that side with that archway. So I think it's safe to jump to a conclusion even right off the bat before we get too deep into this forensic determination that we know that we're getting some kind of a high point in the middle and both sides are kind of separating off, as well as some internal structural issues. Now moving into the master bath, I mean, we're really just seeing large separation here in the finish work, which is just going to be indicative of that vertical movement. The floors, as we're walking through here, are very uneven. You know, just basically being brought either with the perimeter foundation movement is causing some of it, as well as the internal structural issues are causing some of that. So it's all of that vertical movement. You know, anytime you're noticing some uneven floors or cracking in the walls, that's all just going to be signs that there's some sort of movement going on with the house. So now, we're now on the other side of the house from the master bedroom. And again, kind of like we thought we'd see movement over here, we have some more cracking in the drywall, things like that. This one, we're actually seeing some cracking through underneath this window to the point where we're getting some water intrusion. And a lot of times what you see with this vertical foundation movement is some separation in the window, and you get gaps in the windows. And you know, people always want to jump to the conclusion that the window is probably warped from the sun, things like that. People always say, well, we just need a new window. But it shouldn't be ignored that as you get this vertical foundation movement, you're going to get separation from the window, and it's not necessarily your window warping or things like that. As we see this separation through here, which I'm sure you can get a close shot of, that's where this water intrusion is going to be. So there was probably some cracking through here that eventually got wet, which is peeling off this the paint and everything else. So again, all signs of this vertical foundation movement that this whole house is experiencing.
So hopefully, hopefully that video was neat to see. It's always nice to break it up from just hearing stories, looking at diagrams and depictions, and then also seeing something in real life. So I know we are approaching the end point of our time together. So as you all can see, it's important to make sure that we're taking as much time as we can looking at the structure of the home, so we're confident that we noted it to the best of our ability, and make sure that the family feels confident in the report that we're producing. But it is 8:42. Any final questions that our group has?
Are we good on these slides? Do you want to touch on?
Actually, AJ, you can hold it right there for a second. So these slides, as you can see, you can see cracks where they are indeed transitioning. The cracks are indeed transitioning all the way through the wall. You can even see, so the top right slide, as well as the bottom left. Also, all four slides, you can actually see the water stains that's actually emanating from the cracks. So indicating that at one point water was indeed transitioning through. So if there is if the basement is finished with drywall, right, there's no way to be able to see that. That's why home inspections are limited to being visual in nature. We can't discover, it's not reasonable to ask us to discover a latent defect, meaning it's concealed. But important why, if you are helping a family do a pre-drywall inspection, to do your best to see if the crack is transitioning all the way through the wall. I was at the InterNACHI House of Horrors up in Pennsylvania a little bit earlier this year, and they also had a condition to show everyone that, hey, so even though this crack is not more than 1/4 of an inch in width, you can indeed see the moisture staining on the wall, and this is what you want to look out for to make sure that it gets noted, because it does happen. It does happen. Same. So same. So there you can see, just really quickly, everyone, you can see the different types of actual floor joists or trusses, if you will. Everything from solid sawn lumber. You've got the wood eye joists there on the right. You've got the open web floor trusses. So that's the very bottom one on the right there. They are actually becoming more popular. Those open web floor trusses. It's just easier. It's just easier for the builder to run everything through. I will say not everyone loves the open web floor trusses, because how much material is there compared to a solid sawn lumber? Not as much. So in the event of a of a fire in the home, what's going to hold up longer? That open web floor truss or the solid sawn lumber? Thanks, Rob. By the way, I saw your note. So yeah, hopefully everyone was able to get something out of this presentation here. Here you can see, as we were mentioning before, that notches in floor joists, unless you're taking care to only place notches in certain areas, not a great idea, because it is going to reduce the holding power of that particular joist, possibly the system. And it's something it's incredibly common. It is incredibly common to see notched floor joists, holes that are drilled too low. I will say I was actually doing a pre-drywall inspection the other day where the builder and then they run I joists where they've had I guess a decent amount of warranty claims where they're not going to allow their contractors to drill holes, even in the pre-approved spots anymore. Or create sometimes they just create, not even drill, just create the opening in the web because it's creating floor issues for them. So they're going to make those predetermined holes themselves in the factories or request it to be made in the factory, so that way they can better control what the quality of that flooring system is like because they're just seeing too many issues. Very, very important to be cognizant of everything that's of any type of hole or any type of notch. So another way to be able to describe load bearing and non-load bearing walls. So typically load bearing walls, you'll see truss, you'll see them on the perimeter of the home, so on the sides or on the ends, and then you'll see non-load bearing walls towards the center of the home. Now, not foolproof, but as mentioned, you can typically tell if a wall is load bearing because you will see a double top plate, so a double plate on the top part of the wall there. So, um, and also just make sure that when you're looking at windows and doors, I think easy things that we can all do is making sure that you don't see light around the door because and windows because it's indicative of possible movement. It's the same thing for gaps around trim, around molding, windows and doors that are hard to open, hard to close, a sign of a possible larger problem. A window or door that's hard to close with cracked glass is obviously going to be something that's a lot more interesting there because if they did it right, there's going to be a header around the top of that door opening or window, right? That transfers the load around the window and creates that continuous load path. So very important to, even though it's just a window or a door, it may not, or, a defect, it may not be just a window or door movement. Take a look around those areas. Make sure there aren't other conditions that explain that smaller condition that you're seeing. So remember, when you are writing your report, make sure that you are mentioning that, hey, so we are general home inspectors. We are general home inspectors. This exercise today was meant to give you a general idea as to the condition of the home. It's impossible for us to note every single condition or that exists or that may exist in the home. We can only report on what we observe at the time of the inspection, and what we deem to be material that could impact the value of the home itself. So it's important to make sure that you're putting that in the report and in your contract, so that way clients have the proper expectation as to what the experience is going to be like. And what I have found, knock on wood, is that when you set proper expectations up front as to what the experience is going to be like, you're not going to have people coming back to you with questions about why certain things were just not discussed. Were just not discussed in the report. Not required to not required to again to note latent defects. Drywall is up on the walls, on the ceilings. People's families' personal items will most likely be in the home, not required to move those items. So it's important to make sure that you're letting your families know. Any questions, anyone? Questions?
Hey, Phil, great job. Really, very informative. Um, one of the key things, and I put it in the chat, was that you touched on that I think is really important about not rushing and really doing a thorough job and stepping away from the house and getting that view from further away. I think a lot of inspectors don't do that from what I see, and I think that's a really excellent point that you brought up about that. So I just wanted to reiterate with you because that's not something you read in a structural type of inspection, but I think it's important.
Incredibly important. I would say that is probably one of the biggest takeaways that I have throughout my years of doing inspections is not because that the home inspector wasn't knowledgeable, but it's because when you start having a conversation, you're able to deduce that not enough time was able to be spent
Agreed. And if you
around the home
have that
for
client,
whatever reason.
yep. And if you have that client that's asking you a lot of questions, you're getting pulled away and you're getting, distracted from the inspection. So, yeah, like I said, really valid point, really great point that hopefully everybody that was on the webinar tonight really does that and takes advantage of it, especially with scheduling, give you enough time between inspections where you're not rushing because you don't want to be late for that second inspection. But you know, great point, and you mentioned it earlier, and I just wanted to reiterate with you on that. That's an excellent point.
Wilfred also just brought up a good point. Agents always ask how long the inspection will take, or also how much longer is this going to be?
Yep. Well,
I actually say,
my answer is as long as my client needs it to be.
yeah,
I defer
we
to
are
them. Now, there's some
we
clients you're sitting there and having conversations. We're very fortunate because we go out with a team. So there's always at least two of us on an inspection. So we
same.
can kind of bounce people around and, answer those questions while the other, team member is continuing to do the inspection, not not being distracted. And then you push that client off and say, hey, Phil, by the way, Christopher's upstairs. He's going to show you the kitchen in the second floor. Then you can focus on doing continuing the inspection without being distracted because it's difficult when you're out there by yourself trying to do a thorough inspection and answering those questions like you said with the realtor and how much longer is it going to take. It's funny when we pull up to an inspection and there's two of us, the first thing out of the realtor's mouth is, oh, this is great, you guys are going to be done quick. I just roll my
I've heard
eyes
that
and walk
before.
away. What's that?
I've heard that before. We were last summer we did it. We did an inspection on a house that was a little over 10,000 square feet, and it was me and two of my other colleagues doing it. And then I think 3 hours into it, one of the realtors had made a comment and said, "Oh, I expected you all to be done."
I love
So
it. I love it. And then you say, but listen, if your family member or child was buying this house, you wouldn't be asking that question, right? It's funny, we just did a 15,000 square foot house today, and there were three of us. And I always tell my clients, there's three of us. If we're there 6 hours, that's 18 inspection hours because we're not
yeah,
overlapping. Everybody's doing their own thing.
yeah.
And it's interesting because as you know, the realtors, you want them to recommend you, but at the same time you gotta put them in their place to say, hey, it's crazy. But no, you did a great job tonight. It was really informative and doing inspections for a long time, you hit on a lot of key points. And I think structure and electric are the big, everything in this, all the systems are important in the house, but the fact that, structural, you have the thing. I did have a question for you. When you're recommending, do you like, I don't like to recommend a structural engineer unless it's a really major concern, because I think when you
Yes.
put that in the report, you scare people away. For example, when you're talking about the roof framing and stuff like that, sometimes a good qualified licensed contractor can do that as well as a roofer. And it's a little more palatable versus once you hear structural engineer, it's like people get nervous.
So what? So yes, you're 100% spot on. So what I do is I either if the clients are there, I'll pull them aside and tell them what's coming. If the clients are not there, then I will call them once I release the report and tell them about certain things in that report that they will need to focus in on. And I'll say, hey, so just so you know, it says you should have a structural engineer further evaluate this because this is what I'm supposed to tell you. But at the same time, this may be borderline. It's not my role to say that that this is good to go, but just so you know, because this is on a truss, this defect was on a truss. I have to tell you. Well, again, thanks for everyone for spending your evening with us. I know 3 hours is a lot to ask, so we definitely appreciate it. Hope you all found we're able to take some tidbits out away from this webinar, and then we'll see you on the next one.